Hi again, Mr. Johnson. You might remember me from the previous videos, your teacher. So, this is the examples for section 1.6. In this first one, it says, tell whether the figure is a polygon. All right, looking at number 1. Again, the definition of a polygon. Closed plane figure formed by segments. You got some curves here. It's a shape, no doubt about it, but it's not a polygon. Okay, because of those little curves. Number 2, kind of looks like a star. It is formed by a whole bunch of segments. This is a polygon. Now the question says, if it's not, explain why. Well, you said, like I said, it's got those curves on it, not formed with segments. If it is a polygon, tell whether it is convex or concave. Okay, if there's one definition that I gave in the notes, I also explained how I think about it. If you can anywhere draw a segment connecting two vertices, if that segment can fall outside of the polygon, this thing is concave, and that's what we have here. So it's concave. Number 3, all segments are connected end to end. It's a closed figure. This thing's a polygon. And no matter where you draw a segment connecting any two vertices, that segment's inside. That's convex. Okay. Number 4 says classify the polygon by the number of sides. Tell whether the polygon is equilateral, equiangular, or regular, and explain your reasoning. Okay, I'm not going to write anything down for the reasoning. Just listen. So, classify the polygon by the number of sides. Pick a side to start, and then go around and count. So, starting with the red dash, there's 1, 2, 3, 4, 5 sides. That's a pentagon. Now, is this thing equilateral? This side's 3, this side's 3, that side's 3, that side's 3, that side's 3. They're all 3. So yes, it's equilateral. Is it equiangular? Those little arcs tell you all these angles are the same. So it is equiangular. If a polygon is equilateral and equiangular, it's regular. So we have a regular pentagon. All right, number 5, you can look at the picture. There's 4 sides. So this is called a quadrilateral. Now, some of you may know some different types of quadrilaterals and can recognize this one. It's actually called a rhombus. That is a specific type of quadrilateral. The question just says, classify the polygon by the number of sides. There's 4 sides, quadrilateral. Is this thing equilateral? All 4 sides are the same. So yes, it is equilateral. Is it equiangular? Those 2 angles are equal. These 2, with the 2 arcs, these 2 are equal, but they're different from the other ones. So it's not equiangular. That means it's not going to be regular either. So it is equilateral. So we got an equilateral quadrilateral. It's a lot of laterals. All right, number 6. 3 sides. We're looking at a triangle. We have 2 of the 3 sides that are congruent, not the 3rd side. So not all the sides are equal. So it's not equilateral. We've got 2 angles that are equal, but not all 3 angles equal. So it's not equiangular. So it can't be regular. And really, what you're looking at here, it's called an isosceles triangle. We'll talk about all the different types of triangles later on, but it's not equilateral and it's not equiangular. Number 7. Again, I'm just going to pick a side to start. So there's the first side. 2, 3, 4, 5, 6 sides. Hexagon. Hexa is a prefix for 6. Equilateral. You can see the sides with the single dash, but you got these 2 sides here, the top and bottom, with 2 dashes. Those are different. They're equal to each other, but they're different from the other 4. So it's not equilateral. We have these arcs here. Those 4 angles are equal, But there's nothing that we know about these two angles. Because there's no information there, we can't assume anything. That means we got to assume they're different. Okay? So it's not equal angular, so it's not regular. We just got a hexagon. Okay, we'll do this one. Well, let's do this one now. We'll do it real quick. The expressions of those two expressions represent the lengths in feet of two sides of a regular pentagon. Trying to get rid of this blue dot. That's awesome. We'll leave it on there. It's a regular pentagon. That means all the sides are the same, all the angles are the same. So the question is find the length of a side. If all the sides are the same, and these represent lengths of the sides, those two are the same. So we're just going to set them equal to each other. And we're going to solve for x. So I'm going to subtract the 6x from both sides, leaving us with 7x on this side of the equal sign. I'm going to add 54 and a half. That is going to make that 80, 91, and divide by 7. X equals, that is going to be 13. Yeah, x is 13. Okay, the question says find the length of a side. We know what x is. Pick one of your two expressions and plug it in to figure out the actual length of the side. So 6 times 13 plus 36.5. That's going to be, let's see, 60 and mental math, 78 plus 36.5. Adding those up, we got 84 and a half plus 3, 114.5 feet. There's the length of each side. So it's a giant pentagon. Okay, we'll end this video. There's one more. It's a longer example. It's going to be something that you'll see on your homework. Please watch. Bye.